In this tutorial, I will talk about how to measure AC current with the oscilloscope. Let's look at this simple circuit. The power supply generates 10 volts peak to peak at 1 kHz frequency. The voltage is a sinusoidal voltage. So if we want to write it as a cosine function, the peak to peak value is 10, so the peak value should be 10 divided by 2, that is 5. 5 cosine 2 pi times 1000 t plus 0 degrees. Our target is to measure the AC current. Firstly, let's try to calculate the current theoretically. We know for the sinusoidal steady-state current, there are two important pieces of information, the magnitude and phase angle. Let's convert the circuit into phasor domain. The voltage is 5 at 0 degrees volts. The impedance for the resistance, we use CR to indicate the impedance. CC is the capacitor impedance. So impedance for the resistor is just the resistance. Impedance of a capacitor is 1 over J ohmic C. 1 over J times 2 pi 1000 radian per second. Capacitance is 0.1 microfarad. That is 10 to the power of negative 7 farad. We just convert everything to standard unit. The current through the series components is just the voltage divided by the impedance in the circuit. So that is Vs, the source voltage, divided by CR plus CC. Notice that the capacitor and resistance are in series. So 5 at 0 degrees over CR plus CC. We can calculate the current in phasor domain. The magnitude is 0.00266. The phase angle is 57.9 degrees. Amps. In time domain, we just put the amplitude here. 0.00266 amps is equivalent to 2.66 milliamps. Cosine 2 pi 1000 plus the phase angle milliamps. Here we try to measure the current. That means we need to measure the magnitude and phase angle separately. We know oscilloscope can be used to measure the voltages, but not the current. Here, one way to measure the current is that we can measure the voltage across the resistor first. Based on Ohm's law, the voltage across the resistance is the current times the resistance. Resistance is just a constant number, 1000. So the current should be VR divided by resistance, 1000. In phasor domain, the relationship is the same. The current should be the voltage divided by the resistance, 1000. So let's look at phasor domain. The Ohm's law works in the same way. VR is the voltage across the resistance. That is 1000 times I. So the current should be VR divided by 1000. Notice to measure the magnitude of the current, we can measure the voltage across the resistor first, then divide it by 1000. The phase angle of the current should be the same as the phase angle of the voltage. So now let's try to measure the voltage across the resistor. A common mistake is that, let's look at to measure the voltage across a component. Firstly, we need to connect one of the channels of the oscilloscope to the power supply, the positive lead and the black lead of the probe. So that is the first channel of the oscilloscope. Notice here, a common mistake is that someone tried to connect the second channel of the scope directly across the resistor. So the black probe is connected here. Notice here, the black probe for the oscilloscope is really grounded. So here, this point is grounded for channel 1. For channel 2, the black cable is also grounded. So if we connect it in this way here, look at here, this is grounded. This is also grounded. So this circuit is just like we shorted the capacitor. So the circuit has been changed completely. So we cannot get the correct voltage across the resistor. So we have to figure out another way to measure the voltage across the capacitor, across the resistor. Since the resistor and capacitor are in series, if we swap the two components here, it won't change the current through the components. So still the same current flow through the two components here. If the current is still the same for the two circuits, the voltage across the resistor won't change. That is still 1000 times I. So really we can try to measure the voltage across the resistor in the circuit on the right hand side. So the first channel of the scope. So we can connect the second channel of the scope here. We can connect the black lead of the probe here for the second channel. Notice here the two black cables are connected together for the two channels. So let's look at how we connect the circuit. We have two components in series. So here is the power supply. The red cable is the positive terminal for the power supply. The negative terminal is connected here. The positive and negative cable for the first channel of the scope. The positive and negative terminals for the second channel of the scope. So we need to turn on the oscilloscope. So we're going to see the signals of the two channels here. So the channel 1 is connected to the power supply. So here we set up that to 10 volts peak to peak. So we click on auto scale, then quick measure. So here we need to select channel 1 and channel 2. Source 2 is for the voltage across the resistor. So that is 5.37. We select the peak to peak value. So source 1 is the source voltage, that is 10 volts peak to peak. So then we can select the phase angle. Select phase. The phase angle is 55 degrees. So here we just got the voltage across the resistor. We measure the amplitude and phase angle separately. The peak to peak value is 5.37 volts peak to peak. The phase angle is 55 degrees. Notice the peak value should be 5.37 divided by 2. That is 2.69. In time domain should be the magnitude cosine 2 pi 1000 t plus the phase angle here. So we got the voltage, both the magnitude and phase angle. The current is just the voltage divided by the resistance. So that is 2.69 volts divided by 1 kilo ohm. We got 2.69 milliamps. Cosine 2 pi 1000 t plus 55 degrees milliamps. We got both the magnitude and phase angle separately. So let's look at the theoretical value, the nominal values for the current. The amplitude should be 2.66. The phase angle is 57.9 degrees. We need to calculate the error for the magnitude and phase angle separately. So for the amplitude, we use the equation is measured minus nominal divided by nominal. So 2.69 minus 2.66. So the error percentage is 1.1%. Then we need to calculate the error for the phase angle. So we use measured value minus nominal value. That is 55 minus 57.9 degrees. So it's off by 2.9 degrees.